Step 3, joining the different elements together. So remember, we had a certain number of elements. So an element over here, an element over there, an element over here. And each element has a begin point and an end point. So we call these psi1L and psi2L for each individual element L. But what we're going to do in order to have to get rid of this complicated double index here is we're just going to number them with a single index over here. So what we're going to do is first look at all of these elements separately, individually. So, and then let's call this endpoint point 1 and this endpoint point 2. And then we're just going to keep on numbering, calling this 3 and 4, and then this 5 and 6. This is the so-called disconnected numbering scheme, which is a local numbering scheme, which just focuses on one element individually without worrying what happens in the rest of the wider world. Obviously, at some point, we need to bring these elements together. We need to glue them together. And what's typically asked in our case here is that the field should be continuous. If the field is continuous, that basically means that, for example, this thing should be the same. So the value at the point 2 and at the point 3 in the disconnected numbering scheme should be the same. And the same goes for points 4 and 5 over here. So actually, we could save ourselves some unknowns by renumbering the whole thing as follows. So now we have our same 3 elements, but we've connected them. We've glued them together. And then we number them as 1, 2, 3, 4, the endpoints. And this is then the connected numbering scheme, which is a global numbering scheme taking care of the relationships between the different elements. So obviously, this reduces the number of unknowns that you have here, so that's always a good thing. Now, in order to implement this more easily on a computer, people typically like to express this relationship between the connected and the disconnected numbering scheme using some matrices. So see if you can do this for this very simple, almost trivial case here. Let's say that you collect all of the values in the disconnected numbering scheme in a vector. And you do the same thing for the connected numbering scheme. You have a vector of 4 different unknowns here. Can you then figure out some sort of matrix which relates this column vector here to that column vector over there? We'll pause the video and see if you can figure this one out. It's actually not so difficult to do. So let's first make that column vector explicit here. So we have a column vector for the disconnected numbering scheme where we have psi1, psi2, psi3, psi4, and I've made this too small, psi6. So this is all in the disconnected numbering scheme. And we want to figure out some relationship between this column vector and then a column vector of values in the connected numbering scheme. Psi2, psi3, psi4 in the connected numbering scheme. What I really should do is, rather than writing that index here, that's that thing here at the bottom of this whole vector, I should do that for all of the individual elements, but that's a bit too much writing, so let's not do that. But let's think about what we should fill out here in terms of matrix here. Now, psi1 in the disconnected numbering scheme, so if we try and show them both at the same time. So psi1 in the disconnected numbering scheme is obviously the same as psi1 in the connected numbering scheme. So this means that here we have a 1 and there we have 3 zeros. Psi2 in the disconnected numbering scheme is obviously psi2 in the connected numbering scheme, so nothing mysterious is happening there. But then the fun starts with psi3. So psi3 over here actually corresponds to psi2 over there in the connected scheme. So here we also have a 1 in the second position, expressing that psi3 disconnected is psi2 connected. Moving on to psi4 and psi5, in the disconnected scheme, they both map onto the point 3. So if we translate that to an equation, we get the following. And then finally, for the last point, we write down this thing over here. Now this matrix that expresses the relation between the disconnected and the connected numbering scheme is called the connection matrix. Now it's obviously a lot of overkill to write this down explicitly for this very simple case of a 1D problem. But obviously, once you go to more complicated 3D problems, then this is less trivial, and this gives you a straightforward way of doing all the bookkeeping, of making sure that you remember which elements are connected to which other elements. And this is how this is implemented in practice for a more complicated 3D implementation.